Motion theory, the story of humans. Master motion manipulators. Close your eyes and listen. Use your imagination. It's better than any video I can produce, or turn on closed captioning if you prefer to read along.
Welcome to the Deep Dive, where we dig through a ton of sources to bring you the essential insights.
And today, we're tackling a really big idea, maybe a radical one. We're looking at human history through a very specific lens.
Right. Forget the usual narratives for a second.
Yeah, forget kings, empires, all that. Our sources argue that everything humans have ever built, from the very first sharp stone right up to, the latest AI, it's all fundamentally about one thing.
Motion.
Exactly. Motion. Controlling it, steering it, using it.
So that's the core idea we're exploring today. Technology isn't just one invention after another. It's more like this single, continuous effort. This craft of steering motion. And our mission for you, listening, is to really grasp this framework, to start seeing the world, everything you interact with, as these managed systems of gradients, loops, and trying to cut down on friction, or leak, as the sources call it.
And it really starts basic. Think about the earliest humans. Cold nights, rivers flowing. You learn pretty fast that motion moves things. Heat escapes. Water goes downhill.
Survival depends on it.
Totally. We became the species that focused on managing those flows, controlling the cold, stopping heat leak, figuring out rivers.
Okay, let's dive into that first stage then. Early mastery trapping and transforming motion. Stone tools seem like a good place to start.
Yeah, definitely. So shaping flint, it's not just banging rocks together, right? The skill is in understanding how the rock wants to break.
How the crack travels.
Precisely. You learn to aim the crack. You're directing the motion, the force, along predictable paths. It's literally shaped motion locked into the stone itself.
I had never thought of it like that. Okay, so what about taking that tool and, say, throwing it like a spear? The sources had a cool phrase for this.
Right, they call it a package of momentum. And the feathers, they're not just decoration, they stabilize it. It's about phase lock in air.
Phase lock in air. Okay, break that down. It just means it flies straight, basically.
Well, yeah, but the physics is neat. The feathers create just the right drag and lift to keep the spear oriented along its flight path. You're using air pressure to stop it tumbling chaotically.
So you're locking its orientation, its phase with its direction. Early aerodynamics.
You got it. Managing tiny bits of friction to control the larger momentum. And think even simpler, like tying a knot.
That's muscle memory for most of us.
But it's pure physics. A knot is basically a brilliant little friction machine. It takes the tendency of the rope to slip and uses friction to create a secure hold. We mastered thermodynamics without even knowing the word.
Even weaving clothes, managing heat leak, right.
Exactly. Interlocking fibers to trap air, slow down the escape of body heat. It's all motion management.
Which brings us to the big one, fire. The first engine.
And maybe the first great act of outsourcing. Fundamentally, fire is a chemical runaway loop. Heat releases gas, gas burns, makes more heat, releases more gas.
Turning stored energy, stored motion in the wood into heat and light.
Right. Hot air rising, kinetic energy. But the really clever part, according to these sources, wasn't just warmth, it was cooking.
This part blew my mind. Cooking as pre-digestion.
Think about it. You're using external heat to break down tough molecules in food, making proteins easier for our bodies to handle. Less internal work needed.
So we're literally taking some of the work our digestive system used to do.
Yeah.
Its internal motion budget.
Yes. And outsourcing it to the fire, an external furnace.
And that freed up energy.
Which allowed, arguably, for smaller guts and bigger brains. We built an external loop, the campfire, that fundamentally reshaped our internal loop, our biology. It's profound.
That pattern, exploiting existing motion, continues with water and wind, right? Learning to work with gravity.
Absolutely. The key insight was that gravity offers a kind of energy stipend to anything that can fall slowly and in a controlled way.
So irrigation.
It's just slope bookkeeping. You're carefully managing gradients, making water go where you want it, slowly. A water mill, that's a direct coupling trading water falling down for an axle turning round. Pure genius.
Sails make sense capturing wind. But the keel on a boat, the sources emphasize how it converts sideways wind force into forward motion. How does that actually work? Is it just resistance?
It's smarter than just resistance. The keel fights sideways movement really well, which generates lift in the water, sort of like an airplane wing, but sideways.
Oh.
So it lets you use the wind's push without just getting blown sideways. You're essentially locking phase with the water, using the difference between air motion and water resistance.
Locking phase with the water. That's a great way to put it. Okay, moving on. Stage 2, scaling up,
Yeah.
synchronization, structure. Agriculture seems like the turning point here.
Huge turning point. Because farming wasn't just about growing food, it was about reorganizing space and time into predictable oscillators.
Rhythms, seasons, planting, harvesting, enforcing order instead of chasing animals,
Exactly. And what helps manage that order? The calendar.
which isn't just arbitrary dates.
No, it's a phase chart for the sky, tracking the sun, the moon, the seasons, so you know when to plant, when to harvest, betting on the cycle.
And domestication fits in here too, as a feedback loop.
A stable feedback loop. We select animals that fit our rhythms, they adapt to us, and the result? Grain in storage. That's stored motion. Calories, potential energy, saved for later.
Then we get into material science, beyond stone metals, learning heat grammar.
Yeah, I like that term. With bronze, we learn alloying mixing metals changes their internal structure, their atomic motion, to make them stronger, less likely to just snap.
And tempering steel, that always seemed like magic.
It's a precise dance. Heating, then quenching rapidly. You're essentially freezing desirable patterns of motion into the crystal structure of the metal, making it hard but not brittle, controlled internal state.
We even figured out how to abstract motion. Coins. They aren't valuable in themselves.
Right, they represent abstract motion, a promise of future work, portable work IOUs. You carry the potential for someone else's labor, someone else's motion in your pocket.
That abstraction lets us build bigger systems. Infrastructure. Roads seem obvious.
Yeah, roads are just large-scale friction edits on the landscape, making it easier, less energy-intensive to move stuff, reducing the leak.
But social structures too, like writing. Motion's long memory. Scratches that recreate a voice. Moving information across time.
Exactly. And think about law and ritual. What are they? They're social metronomes. Shared beats, predictable patterns that let thousands, millions of people move together without constant collision and chaos. They synchronize us.
Synchronization again. It leads right into geometry, doesn't it? Watching the planets, predicting their motion.
Yeah, geometry became the language for anticipating motion. We saw the patterns. A circle isn't just a shape, it's the loop archetype, the most stable pattern of recurring motion.
And eventually, equations showed that curves carry causes. The shape predicts the movement.
The parabola of a thrown stone, the ellipse of a planet's orbit, math describes the motion.
Okay, let's jump forward. Section 3. Caging pressure, guiding invisible flows. The Industrial Revolution. Steam power.
Right. We learned to bottle the push. That rattling kettle lid, that's the clue. Pressure is caged motion, intense, constrained energy.
And the steam engine turns that cage pressure into loops.
Reciprocating loops, yeah. Back and forth motion, which flywheels then smooth into rotation. Useful work.
But control was key. Those governor things on engines.
The governors, little feedback organs. They sense the speed and adjust the steam flow to keep the rhythm steady, crucial for preventing runaway loops.
And this new speed, these engines, changed society itself. Trains, forced synchronized time zones.
Think about it. If trains are running on schedules across hundreds of miles, everyone needs to agree on what time it is. Local time wasn't good enough. The need for fast, coordinated motion literally reshaped our concept of time.
Wild. The machine made us sync up. Okay, from steam pressure to the next invisible flow, electricity.
Yep. Electromagnetism. It's all about choreographing electron motion, a magnet moving near a wire, or current in a wire creating a magnetic field.
So the telegraph, telephone, radio, they're all
Yeah.
variations on that.
Pretty much. Shake this loop here, watch that loop there respond. It's about locking the phase of electron behavior over distance, sending patterns.
Even a light bulb. The sources described it almost poetically, holding a filament near failure.
It's controlled failure. You heat it just enough so it glows brightly but doesn't quite break. Managing energy leaked perfectly to turn heat into light.
The steady, useful leak. And that leads to electrical grids.
Continental circulatory systems for energy, managing the flow, the pressure across vast networks.
Which brings us pretty much to now, the digital age. The logic still holds.
Absolutely. Just faster, smaller. A transistor, it's still just a valve for electron motion. A tiny switch deciding if a path locks, current flows or leaks. No current, a zero.
Still moving states, just electrons instead of steam. And the internet.
The ultimate planetary packet cascade. Information broken into pieces, sent flying along fibers.
Would you like tunnels for light, right? Keeping the signal, the motion, intact over huge distances. Phase-protected motion.
Exactly. And now, AI. What are we doing there? We're training these complex networks. Neural networks, which are really just piles of interconnected weight
To do what?
to phase lock with data, to recognize patterns, find the underlying rules of motion in complex data sets, whether it's steering a car, predicting stocks, or modeling climate.
They learn the motion, then replicate it or predict it. Motion modeling motion.
You got it.
Wow. Okay, this unified view it's really something.
Yeah.
Seeing Flint tools and AI
Yeah.
as part of the same story of motion management. Before we summarize the core rules, you mentioned biology fits this pattern too.
Oh, absolutely. Life is orchestrated motion. DNA itself has a kind of coding resonance, a pattern that guides construction. Enzymes, they're like tiny, perfect motion traps. They grab specific molecules, hold them in just the right way to make a difficult chemical reaction happen easily. They channel molecular motion, biological catalysts.
So even our brains. There's complex rhythms, coupled oscillators.
That's a key theory. Neurons firing together in coherent patterns, creating thought, consciousness, and think about music. What is it?
Shared rhythm.
It's our oldest trick, getting thousands of people, thousands of bodies to synchronize, to share a beat, feel connected, move as one. Pure coherent motion.
Okay. So looking back at everything, fire, sails, engines, computers, the sources, boil it down. 6 rules for mastering motion. This feels like the key takeaway.
It is. These are the fundamentals of how we manipulate the world. The 6 rules of motion mastery. 1, find a gradient.
The energy source. Heat, height, attention.
Right. 2, build a loop. The device, the institution, the algorithm that harnesses that gradient.
Got it.
3, raise coherence. Get the parts working together, aligned in rhythm.
Efficiency.
4, reduce leak. Minimize friction, noise, wasted energy, lost focus.
Plug the holes.
5, shape coupling. Connect things where it helps the flow. Insulate them where interference hurts.
Smart connections.
And 6, scale without shatter.
Okay, hold on. Scale without shatter. What does that mean in practice?
It means building using holarchies. Think nested systems. Stable parts making up larger stable parts, like cells forming tissues, tissues forming organs, or families and villages and regions.
So small working loops successfully combined into bigger working loops that don't just collapse when they get large or stressed.
Exactly. That's how you scale complexity reliably.
Okay, those 6 rules cover a lot. Trapping motion in loops, making it useful. But this brings us to the big challenge today, doesn't it? We've gotten so good at this.
That we risk, as the sources say, overheating the room.
Climate change, biodiversity loss, even our attention spans being shattered.
They're all examples of runaway loops or destructive leaks from our powerful motion manipulating systems. We're driving some global patterns too hard, generating waste and instability on a massive scale.
So the solution isn't to stop managing motion, but to get smarter about it. Apply the same craft differently.
Precisely. We need to redesign flows. We need to build in more negative feedback where things are spiraling out of control, retune the incentives.
The goal becomes global coherence.
Increase global coherence without exporting destructive leak. That's the challenge. If your amazing new technology, your perfect local loop, ends up trashing the environment or fracturing society.
Then it's a solo wrecking the band.
Exactly. It's failed mastery.
So the big realization here, the punchline maybe, is that we didn't escape physics. We just learned how to compose with it.
Beautifully put. We turned falling water into bread, hot air into exploration, vibrating electrons into poetry.
Everything around us, our phones, cities, maybe even our thoughts. It's all orchestrated motion. Patterns holding themselves together just long enough to do something useful, to remember, maybe even to care.
So the final thought for you, listening, start looking at your world through this lens. Notice the flows, the gradients being tapped all around you. And then ask the crucial question.
Where's the leak going?
Where is the leak going? Understanding that is the beginning of true mastery.